Precalculus, Chapter 4.7, Quick Review. In exercise 1 through 4, state the sign, positive or negative, of the sine, cosine, and tangent in the quadrant. And I'm going to do in this exercise set the odd number problems and leave to the viewer the even number problems. And what we're looking here in exercise 1 through 4 is to find the signs of the trigonometric ratios, sine, cosine, and tangent in each quadrant. Well, to do this, one thing that I've seen used often, I've used it, is the acronym. It goes like this: all students take, and here in quadrant 4, calculus, which is obviously not a true statement, but it serves a purpose here. What this signifies is that in quadrant 1, right here, the upper right, all trigonometric ratios, sine, cosine, and tangent, are positive. In quadrant 2, and by the way, that answers problem number 1, right? So positive or negative, so we'd say that sine theta is greater than 0, or positive cosine theta is greater than 0, and tangent theta is greater than 0. How do we get tangent? Sine to tangent theta equals sine theta over cosine theta. And if both sine and cosine are positive, tangent has to be positive as well. And here in the third quadrant, the lower left quadrant of the unit circle, only tangent is positive, but cosine and sine are both negative. And finally, in quadrant 4, we have cosine is positive, but sine and cosine are negative. So let's go ahead and look at number 3. Okay, in quadrant 3, we have sine theta is going to be less than 0, and cosine theta is less than 0, and tangent theta is going to be positive. Why? Because if we have a negative divided by a negative, which in this case sine and cosine are both negative, we will have a positive. Okay, let's go to the next set. In exercise 5 through 10, find the exact value. And when we're looking at exact values, we're looking at known or special right triangles. And there are 2 of them we work with in Precalculus. And those would be a 30, 60, 90 right triangle, which is something like this. So if we have this angle over here is 30, and its complement up here in the upper right is going to be 60 degrees. What happens, we can represent the relation of the sides by this. The short side would be x, the long side would be 2x, and the adjacent to the 30-degree angle is going to be square root of 3 times x. And the other special right triangle we're dealing with is the 45, 45, 90 right triangle. So if this is 45 degrees over here, and consequently 45 degrees also in the upper right, and each side can be, each of the legs of this right triangle can be represented as x, and here on the hypotenuse that can be represented as x square root of 2 or square root of 2x, however way you will look at it. And so for sine pi over 6, we can look at the unit circle like I showed earlier, what we try to do in Precalculus class is to gradually move away from having to use the unit circle for everything. So I teach my students in different ways, one of which is the unit circle trigonometry song, which goes something like this. Okay. 0 pi over 6 and more. The next one to know is pi over 4. Then pi over 3 and pi over 2 are all of the radians I'll say to you. 0, 30, 45, 60, 90. That's why out of unit circle trigonometry. Got a low key there. So anyway, pi over 6 is over here at 30 degrees. And we put this over here. We have, by the definition of the unit circle, the hypotenuse is 1, or the radius is 1, and the opposite side is going to be 1/2, because we have this relationship x, 2x, and so if 1 is equal to 2x, x is equal to 1/2, and so the opposite side over here is going to be 1/2. So our answer here is sine of pi over 6 is 1/2. Okay. Next, another problem. Oh, by the way, in problem 6, we have a tangent. We have to remember that the tangent theta, call this my tangent identity, tangent theta is going to be equal to sine theta over cosine theta. Y over x, rise over run. Okay, 7, I'll work out number 7. Here we have cosine 2 pi over 3. Well, what happens is, when we get back to our unit circle, we don't have 2 pi over 3 over here in quadrant 1. But you have pi over 3. Pi over 3 is going to be right up here, or equivalently 60 degrees. But 2 pi over 3 is going to be up over here in quadrant 2. And so what we have here is, so we'll be right over here. What we can do is create a reference triangle by dropping a vertical line segment straight to the x-axis, and then our reference angle theta, or called alpha, excuse me, alpha is going to be equal to pi over 3, or 60 degrees. And so this enables us to use our, and the original, and 60 degrees over here on the right, pi over 3, is going to have, we're looking for cosine, well, 1 is going to be our, by definition, our hypotenuse, and the short side over here below is going to be 1/2 of the long side, so that's going to be 1/2, and so our cosine of pi over 3 is going to be 1/2. But here we are over here in quadrant 2, and so the only question we have remaining to answer is cosine of 2 pi over 3 over here to the upper left quadrant of the coordinate plane. Is that going to be negative 1/2 or positive 1/2? Well, it's going to be over here on the left of the x-axis, so x is going to be, or adjacent side here, is going to be equal to negative 1/2, and therefore our cosine of 2 pi over 3 is negative 1/2. So I'll write here cosine of 2 pi over 3 equals negative 1/2. Okay, the next odd number problem, sine of negative pi over 6. Well, what we have here is, I'm going to draw a coordinate plane here, and if we go to negative pi over 6, that's going to take us down clockwise pi over 6, so I'll put negative pi over 6 right here. So that's going to be this angle here, and if we go ahead and make a reference triangle by going straight up, in this case to the x-axis, that's what we have. And this is going to be a reflection of pi over 6 angle above the x-axis. So it's like the unit circle comes like this, hits here, goes like this, comes down here at negative pi over 6. And so what do we have here? Well, that's going to be, our alpha is going to be our angle here, and that's going to be the reference triangle. Well, the sine is going to be opposite, which is 1/2 over hypotenuse. But down here in quadrant 4, we're going to be down below the x-axis, so our opposite side over here is going to be negative 1/2. So what we have is negative 1/2, which is our opposite, over our hypotenuse, and so that sine of negative pi over 6 is going to be equal to negative 1/2. So that is number 9. The last problem I don't plan to do, but we'll take a brief look at it. We have 10, which is cosine negative pi over 3. So I recommend drawing the angle and getting a reference angle similar to the way we did problem 9 and figure that out. I hope this has been helpful to you. Good luck, and thanks for viewing.